So today we're going to start talking about linear equations. Linear equations show how the x and the y are related to each other in a given situation. We've talked about this a little bit in functions, or when we are identifying what a function is. We talked about this with domain and range, with the domain values being the x and the range values being the y. But now we're going to show how these things are related to each other in an equation. Every situation will be different. But it's important to remember that each one of these is just a way of showing how the x and the y are related to each other in a certain situation. First, we're going to talk about the three types of linear equations. One is slope-intercept, where you are given a slope, which is represented by the m, and you are also given the y-intercept, which is represented by the b. The slope is always the number that is with the x. The y-intercept is always the number that is by itself. Another way that we will see equations in algebra is the point-slope form, where you are again given the slope, which is represented by m, so that doesn't change. But instead of getting the y-intercept, you are given a point that is on the line. Right? It could be any point that is on the line. It doesn't matter because you're going to end up with the same equation no matter what. It doesn't matter which point you pick. But we'll get more into that tomorrow when we discuss the point-slope form. And finally, the third way is standard form. All right? In standard form, they don't give you any information. They don't tell you what the slope is. They don't tell you what the intercept is. They don't even tell you what a point is. Standard form just puts the x and the y on the same side of the equation and makes it equal to some number. And again, we will get more into this when we talk about it later in the week. But today, we want to focus on the slope-intercept form. As you can see on your paper, slope-intercept equations will always have the letters x and y in them. Okay? Those are the things that are changing. So the x and the y will always be in the equation. Doesn't matter what else is going on, there's always going to be an x and a y. The slope and the y-intercept in slope-intercept form are going to be numbers. These are numbers that'll depend on what is happening in the problem. The slope, or the m, is also called the rate of change. It tells you how much y is changing for every x value, or for every time we change x by 1, the m is telling you what's going to be happening to the y number. The y-intercept is the starting point. It's considered the starting point because that tells you what y is equal to when x is 0. If we made x 0, no matter what the m number would be, we multiplied it by 0, it would be 0. So all we'd be left with would be the b. So we'd have y equals whatever that b number is. So we just consider that the starting point. So that's how you'll see it in an equation. The m number is the slope or the rate of change. The b is the y-intercept or where you're starting from. Sometimes we'll get verbal descriptions, or before we even talk about that, let's look at an example of an equation. We have y equals 4x plus 3. This is on your note page. The 4, or the number with the x, is the rate of change. It is the slope. Every time we make x bigger by 1, we're going to be making the y bigger by 4 because we're multiplying that x by 4. Our starting point, or when x is 0, would be 3 in this situation. That's our y-intercept. If we made x 0, multiplied 0 times 4, we would get 0. So it's like it would cancel out, or it wouldn't be there anymore. And then we would just be left with the 3. So y would equal 3 when x is 0. That's why it's our starting point. That's our y-intercept. All right, we can see this in a word problem also. And I made a very simple one just to show you. It's going to result in the same equation that we just had on our paper. The 3 apples is what Joe is starting with. So that's going to be our starting point, or our y-intercept, or our b number. That doesn't change. Doesn't matter what else is happening. Doesn't matter if those apples are going to get eaten or if he's going to add more apples to them. You're starting with 3 apples. Then the rate of change is that every single hour he's going to add 4 more. So the number in front of the x, which in this problem would represent the time, the hours, every time an hour goes by, Joe puts 4 more apples into his pile of apples, and then that would be the total, which would be the y in this situation. So you can see how this word problem is the same as the equation, or how you could get the equation out of this word problem, and why those things represent what they represent. Why the slope is the rate of change, and why the starting point is the b number or the 3 apples.